Hi, this is the demo video for eHealth Assistance IoT project. eHealth Assistance is an IoT platform designed for managing retirement homes and monitoring their guests. In order to monitor the health status of patients, they have to wear some small sensors, smartwatches, wearable thermometers and wearable accelerometers. The whole project can be summarized and described by the use case diagram in the figure. It is an IoT system created thanks to the object-oriented programming. MQTT and REST are the two communication protocols used to coordinate the various elements. The communication through MQTT protocol is achieved thanks to Mosquito Message Broker, which distributes messages from publishers to subscribers. The service catalog is the entry point for all the components of the system. The service catalog registers and provides the services available in the network, exposing JSON-based RESTful API. It also receives registration by each component in the system through PUT requests. First of all, the register catalog registers its availability in the service catalog. The register catalog is the second entry point, and it collects all the information about homes, patients, devices, doctors and nurses. As you can see, in the service catalog there are all the information necessary to connect all the elements of the system, such as the message broker, the microservices, the device connector, the register catalog, Telegram bot, and all the others. In the register catalog instead, there are informations about the retirement home, doctors, nurses, and patients. Telegram bot is an instant messaging software which allows the communication with users. In the system, there are two different bots, designed respectively for nurses and doctors. Every microservice communicates with the catalogs. For example, nurses can use Telegram bot to modify the register catalog by adding and removing patients and contacts. From the Telegram menu, nurses can register a new patient in the retirement home. During the registration, the bot asks some questions: name, surname, and date of birth of the patient, and the sensors worn by the patient. Then, the new patient is automatically added to the register catalog thanks to a POST request. Moreover, nurses can remove a patient from the retirement home following a similar procedure. The elimination of a patient happens through a delete request of the REST communication protocol to the register catalog. The Telegram bot designed for nurses also offers the possibility to request the emergency contacts of patients. After entering the desired patient name, the associated emergency contacts will appear, ready to be used. Moreover, it is also possible to add new contacts or delete contacts for that patient. All this is possible thanks to GET, POST and DELETE requests to the register catalog. The data collected by the sensors are distributed within the system by the device connector. The device connector deploys data to the actors with MQTT communication protocol. It sends heart rate, geolocation, acceleration, body temperature in different time steps to the respective microservices which analyze them, while saturation, steps number, breath rate are directly sent to ThinkSpeak adapter. Heart rate, pulse, and body temperature microservices analyze data and send processed data to ThinkSpeak adapter. ThinkSpeak adapter adapts and collects data from the device connector and microservices to store them in the ThinkSpeak platform by REST web services. ThinkSpeak is a platform as a service used to aggregate and visualize data streams in the cloud. The four microservices manage, analyze data and publish alarm messages on Telegram bot in case of abnormal conditions. The communication between microservices and Telegram bot is via MQTT. Now, let us analyze the tasks of microservices in detail. Let's start with the heart rate microservice. The microservice deletes outlier values, analyzes and labels the entry data based on standard ranges. It uses a JSON file which contains the range of normal and abnormal values of heart rate in two parts of a day, night and day. In case of abnormal values, the microservice publishes an MQTT message containing the cardiac arrhythmia alarm. Telegram bot is subscribed to the topic of this message, so it sends an alarm message to the nurse bot. Only nurses to the same retirement home of the patient can receive alarm messages. The alarms published by the heart rate microservice are of three types: fibrillation, bradycardia, and tachycardia. The second microservice is body temperature. This microservice takes 10 consecutive temperature values received via MQTT. It deletes outlier values and it calculates the average of the correct values. This is done to increase the precision of the measure. If the average of them is greater than 37 Celsius degrees, the alarm message is published. After receiving an alarm, the nurse can change the sampling frequency of the temperature for that patient. If nurse changes the frequency, the system saves the new frequency in a JSON file. Only when the patient does not have fever for 3 consecutive times will the initial sampling frequency be returned. Then the patient will be deleted from the JSON file. The third microservice is false. The false monitoring microservice is set to send alarms when a patient falls. It analyzes the value of acceleration sent from the device connector, and if the value is greater than a threshold, it waits for the following value. If the second value is lower than another threshold, meaning similar to the gravity acceleration, an alarm message is published through MQTT. The microservice stores the data of the patients in a JSON file. The fourth and last microservice is geolocation. This microservice is subscribed to the patient location MQTT message topic. As soon as the location is received, it is compared to the retirement home location, which is stored in the register catalog. If the two positions are different, a MQTT message is immediately published. On Telegram bot, nurses receive an alarm message and also the map of the patient's current position. The patient is also inserted in a JSON file which stores the removal of the patient. When the patient returns to the facility, Telegram will send a specific message to the nurse bot.
Telegram bot also interfaces directly with the device connector via MQTT protocol. The nurses and doctors bots can request the current parameters of the patients, how in this example. The user should insert name of the desired patients in order to get the list of the patient's vital signs. The exchange of MQTT messages occurs between Telegram bot and the device connector. There is also the communication between a TeamSpeak adapter and Telegram bot by the MQTT protocol. The doctor, through the bot, can request the trend graphs of a patient's parameter. The user should insert the name of the desired patient and he can set the data age between daily, weekly and monthly and the variable of the graph desired. Then, TeamSpeak adapter sends to Telegram the information requested by the user. For both Telegram bot in the help menu can be found a more detailed and complete description of their functionality. Telegram bot is not the only user interface used in this IoT system. A doctor's dashboard was also created thanks to Streamlit. It retrieves data from TeamSpeak platform exploiting REST web services. The doctor can press the button on the Telegram bot menu to reach the web app. It is possible to access to the doctor's personal page only after typing the correct username and password. In fact, in this example, the password is incorrect and so the access is denied. Streamlit compares name, username and password of doctors for the specific retirement home in the register catalog JSON. After the authentication, the platform generates the doctor's personal web app. The doctor can choose the patient and the data age of the graphs, and then he can set in the same time also another patient with another data age of the graph. On the web app, doctor can visualize statistical parameters, trend of daily average parameters, and some statistical graphs. At the end, in the section Info Patient, the doctor can take a look at the general information and contacts of each patient of the retirement home. Thanks for your attention.